Hello, in this video we will practice on logarithmic functions. The function f of x is given as log 3 of 3x plus 1. Okay? So given that, we need to find the inverse of this function. So in order to find the inverse, we say f of f inverse x is equal to y. Okay? So this means f of y is equal to x. Okay? If we substitute y for x in the expression of f, we need to end up with x itself. Okay, let's substitute y inside there. So this will be log 3 of 3y plus 1, and this is basically equal to x. Okay, so this means 3 to the x is equal to the 3y plus 1. So 3 to the x is equal to 3y plus 1. Okay. So we need to find y, right? Because this is what we have for inverse. Okay. So if we isolate y from all the other terms, we need to take this negative, this 1 to the other side. So this will be 3 to the x minus 1 is equal to 3y, and then this will be basically equal to 3x minus 1 divided by 3 equals y. Okay, so this is what we have for y, and we know y is the inverse of fx. So inverse fx is equal to 3 to the x minus 1 divided by 3. Okay, so this is what we have for the inverse of f, given f in this form. Next, we have an expression, a number, log 3 of 5, and it's equal to a, and we need to find log base 5 of 15. Okay, so this is what we need to find. Okay, let's start with this and say log base 5 of 15 is equal to what? I can rewrite 15 as 3 times 5, right? This is something I can do. So this is log with base 5 of 5 times 3, okay? Now we have a product inside the log, okay? So we can separate them as summation of each individual term. So this will be log with base 5 of 5 plus log base 5 of 3. Okay. Now we see log base 5 of 5. This is basically equal to 1. And here we have log base 5 of 3. Okay. So this is similar to what we have for a, but instead the base and the inside the log has to interchange, right? This is what we really need to do. So we know we can do this by taking the reciprocal of this number. So this will be 1 plus 1 over log 3 base of 5. Okay? So when we do that, we have everything we need, basically. So log base 3 of 5 is equal to a. So this will be 1 plus 1 over a. Okay? So it seems like we can find, or we can rewrite this expression as 1 plus 1 over a in terms of a. Okay? So this is the second example. Thirdly, we have an inequality, and we need to find an interval, or whatever it is, some sort of expression for x. Okay? So now we have log with base 2 of something, and this is bounded by 0 and 2. Okay? So this means this log is greater than or equal to 0, means 1 is greater than or equal to x minus 5, right? This is what we really have. Okay? So in the next one, we have for the other bound, this means log base 2 of x minus 5 is less than or equal to 2, means the inside of log has to be less than 4. Okay? Because if it is beyond 4, then the power has to be greater than 2. Okay? So when we solve this for x, we will get x is bounded by 9 from the above, and it will be bounded below by 6. Okay? So our x is inside the domain x through 9. Okay. Now, when we have this expression or this interval for x, we need to check if anything bad happening for any number inside this interval. Okay? So for any given number, for example, if we have any number between 6 and 9, is there any issues with the definition of log or anything else? So for example, we cannot have negative numbers here inside the logarithm. Is it negative for any number inside this interval? No, it's not. So we can basically use any number here, and it will be defined everywhere. So this means x is really the set given here. So this is where x belongs. Okay, that's all for this examples. Please feel free to ask me if you have any questions. Bye.